easily, and so this is my interest in databases is around the ability to keep track of population, more or less. So, and I've been playing with PostGIS for about 2.5, 3 years. I use a little bit of it for work and sort of just for fun. And so this is a talk on that. And it'll be sort of tutorial-ish. So what I was thinking is I would sit at a table, sort of work through some code, answer questions as they came up. So that's the presentation I have. I don't have a very funny, sort of good for a big audience, cool slide presentation. So it's sort of important that you ask questions, because otherwise it won't really work so much the same. So first of all, how many people have used PostGIS or know how to model? And okay, that's a good question. How many people have used PostGIS? Okay, how many of the remaining 4 know how to model sort of geographically with polygons and points? Okay, so basically PostGIS, the way you model geographically is, as you know, through points, lines, and polygons, and then you attach a row of data to a geography, typically if you're doing it in an ESRI world. And that's how you get attributes like percent Hispanic or what have you, how many Trader Joe's there are in a zip code or whatever. PostGIS and all the other database extensions to that sort of flip that, and you store the geography in a row in a table, and then just grab the attributes as you want them, because they're there already, and the geography is just another one of the attributes. This is a way better system because you can also store multiple geographies per row, which can make a lot of sense in an ER entity relationship sort of world where you've got a zip code polygon, you've got an outline of it, but along with that entity might go the centroid, might go a simplified polygon, might go any number of things, any number of geographies. You don't have to store them in a separate shapefile and then link to the DBF. They're just there, and you can create them on the fly, and it's great. So, can like you see that? Can you see that top row, the select star from blah blah blah?
Not really.
Not really. Okay.
I can see that there's the top row.
That's a start.
We can see it. We just can't read. Let's just begin.
And I think before I blast into this, given that there are enough PostGIS users, we might have some common ground. Does anybody have any questions about PostGIS that have been bugging them as they've been trying to use it? Like about getting shapefiles in, about what the geometry columns table means, about spatial reference. That is a stumbling block for many people that you all seem to have gotten past. So the geometry columns table is a metadata table that stores the names of all the columns that have geographies in them in your database, as long as you populate it correctly. And if you're drawing maps using other software than PostGIS, I'm just going to pull up a chair. You would use that. You would need to have all the geographies you want to draw in that table. So something like QGIS, or at some point ESRI products will recognize what geographies are there and can draw them. So just to look in my large font system, there's one record. So we've got the catalog, the schema, the name of the column, or the table, the name of the table that the column is in, which is Oregon, Washington, TR, which stands for tracks. You've got the name of the geometry column that this row is referencing, called the geom. You've got its coordinate dimensions, which is 2, which means it's flat. They do allow for 3 if you're storing z-values. You got the SRID, which is the number that corresponds to its projection, which is, in this case, latitude, longitude, 4326. If you only know one, remember that one. And then you've got the type, so it's a multi-polygon, which means that it's polygons, which are polygons on a surface, except that one shape may have multiple disjoint shapes as sort of bundled with it. So with a zip code, you will have a single zip that may span a river, and in that case, you'd have a polygon, a simple polygon on each side, perhaps, but it would be a multi-polygon shape in here, because otherwise you'd have to break it up, you know, in sort of an unnatural way. Yeah, so that's, and then we have Oregon, Washington zip, so that's zips. We have some redundancy, that's good. Oh no, these are, yeah, those are redundant. I have not inserted the centroids, so we'll do that in a second. Any questions? So these are straightforward SQL statements. We're going to alter the table Oregon, Washington zip, add a column, the geom centroid. I don't think we're picking up the underscores that are under. There. The underscore there, because of the font weirdness. But so it goes. So we're going to add a column that's going to store geography to that table. We're going, so the row after that is that we're going to update that column and set it to be the centroid of the original polygon geometry. And so a centroid, for those of you who haven't been in high school physics for a while, is you have a polygon and you basically, so it's a shape, it's a shape that has space extent, and it's the point at which that shape would balance, sort of this way. So it's often a measure, it's often a useful punt if you are trying to do something like give me all the Trader Joe's within 10 miles of my zip code. You would, and sort of the way this tutorial runs is assuming that you would take the centroid of that zip code and then draw a circle and say, give me all the Trader Joe's. It would be more sophisticated to do it using your polygon or using some more sophisticated measure because, but.
Also, especially considering the zip code is, like, when you have a zip code database of geospatial stuff, the location is actually the location of the post office. So
Well,
if you want something that's within 5 miles of my house,
maybe this is better because
yeah,
this is, yeah.
Better, because if you say, like, you know, within 5 miles of my house and you give your zip code, it's actually within 5 miles of the post office. And it's usually, the post office is within 5 miles, because it's the other zip codes within 5 miles of the thing, so that's why this is a better.
Yeah. So
most people don't know that. They'll download like a GeoIP database. It's got like, here's the zip code and here's the geo, here's
and the
the
point
lat long.
for the zip, and it'll have a point.
Yeah,
with
yeah,
that,
that's
yeah.
the point. And it's, you know.
And it's some random building, like.
It's the post, no, it is the post office. That's the official, like.
And so probably for 97215, which would be the east side, I think that post office is in Grand. And then the zip code extends sort of from probably a block away from that near the river to
Right. So
Mount Tabor or something.
Let's say a social networking site, and you put 97215, and you're like, find me all the people within 1 mile of 97215. It's like finding all the people who have the same zip code as the post office is within 1 mile of the post office of that. So it's a weird.
Yeah. Zip codes, and an aside is if you're doing data analysis and you can avoid using zip codes, if you're doing population analysis, so you want to know how many people we're doing something on foreclosures, you know, what are the foreclosure rates of whatever. The only data we have is by zip code. We get a record, or there's other data, but the only data we have. We get a record which has the zip code, so we're calculating the rates using that. But it sucks. Like zip codes change. Even since 2000, they've added zip codes to the Portland area, so you get weird denominator things if you're trying. They suck. Use tracks, like figure out census geography and use it. It's not very hard if you know how to do this sort of work anyway, and it's so much better. And the post office hates the fact that people use zip codes because they're like, we don't want to we don't want you calling us up and yelling at us when we change it because your model doesn't work, or you don't know how to be a real estate agent anymore because our zip codes are different. We don't care. That's not our problem. We just want to deliver mail. So do them and yourself a favor. So, and don't use them if you don't have to. So we added a column, update Oregon Washington zip. Now we're going to call select populate underscore geometry column underscore columns. And what that's a PostGIS function which goes out and looks for all the geometries in your database and adds their metadata if it's missing to the geometry columns metadata table. So that they can then be found and referenced more easily by other programs. This is a great function. It used to be you had to do it by hand. And there was no sort of update everything function, and it's really nice. Then we're going to try to select star from geometry columns and see that it's there. And then we'll create a spatial index on the new centroid that we've created. So I'm going to cut and paste. Any questions or? So there's our new, the populate geometry columns function added this row. That's the geom centroid percent, and which table that it's in and all. And you see that instead of being a multi-polygon, it's a point, because a centroid is a point, just a zero-dimensional thing, as opposed to a polygon that has 2 dimensions. So we're going to create an index. This is just, if you don't create lots and lots of just indexes in your life as a Postgres person, it's nice to have sort of a paradigm to cut and paste. That's it. There's just a little bit of different notation where you say using just and then that instead of just. Create index on or Washington zip, and normally you would just say parenthesis, the geom cent, close parenthesis. So, let's see what we got here. So now what we're going to do So first of all, we're storing the geographies. That's just binary data that's stored in a blob with a lot of magic to make it better. So if we look, at one of these new centroids, we just get a binary spew that looks like curl code. But that's not very useful. So to us as users, so we want to grab the latitude and longitude out of that, and that would be this. This is an illustrative select statement. That's what this will do. So we're going to select blah blah blah. We know how that all works, and then in here. There's an underscore right there, just so you know. We are going to get the y value of the geometry centroid, turn it into a numeric. I can't remember what it is, but it doesn't round, whatever it is. And then we're going to round it to 6 decimal places, and we're going to return it as a latitude. So an xy plane, you have your x here and your y here, so your y is your latitude because you're going up, and your longitude is your across. And that's the other row does the same thing. And we're going to look at, I think we're going to look at 3 of them instead of 10 of them because of the font size. Hopefully this will just work. So look at that. I don't know where Antelope, Oregon is. I bet it's pretty. Is it dry? Is it out there? Yeah, so 40, that zip code is 180 people, so that's sparsely populated. The median household income is actually what that is. And 42, so that's not actually dirt poor. The latitude is 44.8, blah, blah, blah. So Salem, they have that marker on the freeway that says you're now halfway up, it's 45, so it's a little bit below that. Probably about 20, 30 miles. And then the longitude is 120, so we're about 121, or like a high 121 or something, if I remember. But, and that's that. Questions? That's a geographic query, etc. One of the nice things about PostGIS is that you can get various other representations of geography directly out of it. So I have not had the pleasure of actually writing something with GeoJSON as an integral thing yet, but when I do, so this should work with any of the, directly, unless there's a bug, with any of the Django things or any of the various things that use GeoJSON natively. And then it's got the zip code again. So it's a select ID, and then st underscore as GeoJSON, and then your binary geography in there. So that's nifty, and there's KML, and there's all sorts of whatever other things you might want. Questions? You guys are a little advanced for tutorial, I think. When do we end? It would be nice to have a chat about what people are doing with PostGIS, if that's okay. We end at 10? Okay. So I'm not going to do the centroids for tracks because I don't think we need that. Oh, we do, just for... fingers. So I'm just with that, we've got a new set of centroids for tracks. I just have boilerplate code in case I need to drop them, but I usually don't. So now here's a function that returns you some geographic information. Which is basically calculates the distance between the centroid of a tract and the centroid of a zip, and returns that. I'm just going to run it, but I don't know that. Does that seem straightforward to everybody, or? And then look at that.
And this is
the distance between the centroids
yeah.
of the tract and the zip.
Oh, centroid.
Yeah. And it's in kilometers, because the sphere function returns meters. So this is, one of the ways you could say, give me all the tracks within 10 kilometers of my zip code, or vice versa. finally, this stuff basically creates a crosswalk between zip codes and tracks. So, I mean, this comes up in demography where you need to estimate the population of, say, a zip code, and all the data you have is track data. You have the population of all the tracks. Because you're working for a realtor and all they know about are zip codes. So what you want to do is you want to find all the tracks that belong to a zip code, and you also need to find what proportion of the total zip code area that tract has. And this works. It works to give a number. My proportions may be reversed. So before you use this for something real, make sure that. So create table crosswalk as, select the zip. They're both ID stores either the tract FIPS or the zip code. So ID in the first table is the zip, and then the second table is the FIPS code for the tract. Then just populate area, the proportion of the zip, the proportion of the tract as zeros. Calculate the intersection, the spatial intersection of the zip code and the tract. Does that make sense to everybody? What a spatial intersection is? You've got the zip code and you cut a piece out of it, sort of where the overlap is, and you've got a new polygon geography. Then calculate, and then it's retrieve the original areas, the original geometries as well. So we've got the first geometry is zip geometry, the second geometry is tract geometry. From the two tables, where they intersect. So this is just an inner join, and we will throw out all the non-intersecting geographies. Because we've done indexes, the indexes are based on bounding boxes. So you take a zip code, this is all funky shaped, and then you draw a bounding box. It's basically two corners. And the index will, when you've got, I should run the explain, I haven't, but what it should do is first only look at the ones where the bounding boxes overlap, which is a totally cheap operation. And then, if the bounding boxes overlap, actually do the geography operation too, and see what the answer is. So that's how the index works basically. That's why we.
So the intersects uses that automatically?
It should. I haven't run explain on it, but it definitely should. Yeah. And I think that's. Is that me? Is that a hint? Are we going till 10 or are we going till 9:45?
No, that was just my personal.
Oh, okay. It's a hint to you, but not me.
I wake up at 9:45 on weekends. That's just what I do. So I have to wake up now.
Huh? She might start asking questions. We create that. We create indexes in there, just for grins, for later really. And then these update things calculate the numerical proportion of the original geometry. No, the intersected geometry, which should be sort of small because it's where, say, a funky zip code intersects a funky tract. You might have something fairly small. That area over the area of the zip code geography. So this will always hopefully be less than 1, because these will both always be bigger than that, because the geom is the product of an intersection, or the result of an intersection. And the tract geometry and zip geometry are before that intersection happens. So it updates that proportion, which I don't use, but you could then use if you have 4 tracts that each have a population of 5,000, and you have the proportions being, 0.4, 0.2, 0.1, and 0.3, you multiply them all together, and you multiply the population by the proportion, and then sum them, and you get sort of their allocation to that part of the zip code. That's that. We'll run that just to see what happens. In this particular set of code, about 1 out of 5 times it's crashing the back end. So I will file that as we're working on it. It'll take a while. I have to like run a script that basically does it over and over again and finally craps out on the last cycle. And this will take a while, and we'll see. I think it's cool, the answer that we get. But any questions?
What exactly is a crosswalk?
Well, a crosswalk is a demography buzzword. That's how do you take one set of data, either like a different year or a different geometry for the most part, and sort of derive another set of data. So this is the crosswalk between zips and tracks. We've got a bunch of, say you have a bunch of track population information, you want to sort of estimate the zip code information, you use this to go between. So it's definitely not a database term or anything like it.
What sort of operational is it? Like, if you have, what did you say, for example, zip code data and some other data, how does it actually figure it out? Like, is it finding intersections between data points?
Yeah, so you know, this is 100, this is 50. Whatever. And you want, so you know what the numbers are for each of these. And you want to find the number for the black. Then you take this area over that area, and multiply it by 100, and then add that, and then take the proportion of the
Develop your boxes on top of it and figure out what your geometry inside does.
So you figure out the area of the zip that's intersected, and put it over the total area of whatever it's laying on top of. And then you get the multipliers, and you can use those multipliers for whatever, like housing units or population. It's sort of dangerous in that, especially with zip codes, not so much with census tracts, but especially with zip codes, you might have like all your population is right there and right there, and none of it up there, and it's all screwy. Or the tract, maybe a better example or a better explanation here would be with the underlying things where you know the population. That might be a big apartment complex that's there that actually should not, and this is just farmland, and it should not get allocated to that piece, but it does when you don't know any better, basically. So, I mean, it's not a really deep thing, but it's sort of cool. And so that's the result. So the proportion of, so hopefully the proportion of tract 41051, that stands, 41 is the FIPS code for Oregon, 051 is, I'm almost sure it's Multnomah. It should be Multnomah. And then there's a number that's the actual tract. How much of that tract? I think it goes, how much of that tract is in the zip should be the prop zip, so a very small amount. So if you were to you know, allocate stuff from that tract, you just use a little amount. And then don't run a shuttle on this particular query yet. Let me work on it a little while. It's on a GitHub thing if you care. The way it's supposed to work is that, again, like with the FUT one down, the amount of that, of the zip that's in that tract, the amount of that tract that's in the zip is almost all of it. So that's a fairly large zip code with a smaller tract that's just inside it. And the amount of the zip code that's in the tract is about half. So there's, you know, about half of the zip code is left. And that's, yeah, so, any questions? Off the top of my head, I think that means that the entire tract is contained within the zip code. That's what it's supposed to mean. And I did this Friday night, you know, and haven't yeah. So that means so then if you wanted sort of what you know, you just multiply by 1. Just be like, oh, all of that goes there. You don't have to divvy out the
Record 28 was like track was entirely in it, but there was like some sort of data rounding error.
Oh yeah, there's quite possibly data rounding error. There's quite possibly poorly drawn geographies, especially with the zip codes, because they don't care. I don't even know if the USPS actually ever releases boundary files for their zip codes. I think they're often done by somebody else, because they're like, we don't do that. We are not in the business of doing this, please.
If they release it, they get sued.
Yeah, or at least yelled at.
I don't remember buying boundaries.
Huh?
Well, when I've gotten zip codes, I don't remember getting boundaries.
Well, I mean, like, ESRI generates the boundaries. The Census Bureau generates the boundaries. I don't know. I think logically they're not considered to be polygons within the USPS. They're considered to be routes, and they're stored differently. They don't store polygons and then say, look them up and say your zip code is blah blah blah. They store something else and then do that. But you can get approximations to it because.
So why is so much data used zip codes? It's pretty much worthless.
Well, the thing is that you know your zip code.
Yeah, but it's not like you tell. It's not like people ask, oh, what zip code do you live in? I mean, people don't really think about what zip codes are.
But other people think about what zip code you live in. Only every marketing anything. You know, so if you're doing, that's why there is a TV show 97 whatever, because that's a rich zip code. Huh? Beverly Hills, yeah. So the reason they're used is because they're available. Yeah, so you can always, it's fairly easy in the US to attach a person to a zip code geography. That's why they're used. And it's really hard to attach them to a tract geography. In the sense you have to geocode it and you have to, if the zip code you just, that's your zip code. And then I'll just take a swipe at realtors and business people. They don't know what tracts are. Tracts are far better for doing data analysis,
Oh, yeah.
but they don't know what they are, so they don't use them. You know, they've never heard of tracts.
Zip codes are optimized for a truck background.
Yeah. And they reserve the right to change them every 3 months, and they do. Yeah, I think on purpose. Now, I think they want to, like, they actively try to discourage data analysis with zip codes because they don't like it. And so, yeah. They're a decent approximation. I mean, for the how many Trader Joe's give me a list of 10 Trader Joe's, zip codes work really well.
Yeah, but zip codes can be really weird shape. I mean, you
Yeah.
say, give me a Trader Joe's that's within 5 miles of my zip code. You could actually miss these Trader Joe's that's in your zip code because the zip code is more than 5 miles long.
Especially if you do a centroid or something. I mean, you could also do like, you could do a buffer, you know, which would take the zip code polygon, assuming you have one, and pump it up. They're a hack. They're a pervasive hack.
So that's what we use. We do speech applications, we do store locators, things like that. So often we'll either do centroids to find like the nearest one. And for most people, they just don't want something up 30 miles away. So
And especially if you're generating a list.
yeah,
Like it's one thing if you're just going to pick one, and then it needs to be right. But if you're going to give me 10 Trader Joe's, then I'm going to look.
right. The other thing that we use it for is great is from the U.S. PS data, we can get back all the streets and the zip codes and then the ranges on the streets. So we do catalog of class apps and stuff like that. So rather than trying to collect somebody's address, I mean, we're not going to have a grammar that's got speech grammar that's got every street, you know. And so what we do is we'll ask for your zip code. Well, first we'll try to target zip code and try to get it, but otherwise we'll ask you for your zip code. Now we populate a speech grammar with every street that's in that zip code. And so then now it's a lot easier to recognize the street. And then we also know all the valid house numbers on that street. And so when we ask for your house number, you know, now it's a very constrained grammar. And you can do the same thing for web apps.
To match their speech.
Yeah, so,
So there's only 10
yeah,
that it has
you
to
want
be.
a catalog, and so but like free-form grammars for like, you know, some long street name, you don't want to have a huge grammar for that. You want to constrain it as much as possible. The zip code allows us to constrain only valid streets in that region.
And you don't ask them for their FIPS, their track
Yeah.
FIPS.
Yeah, maybe. We'll give that as an option. Your zip code or your track.
As an alternative, I keep databases running around that are like neighborhood databases. Does anybody use those? Because people generally don't understand.
I'll let you weigh in too. No, because they're interesting for analysis, because there is some sense like, oh, that really is a neighborhood. But there's all sorts of wiggle, and people, I think for every 10 people that know what their zip code is, probably 4 know what their official neighborhood is. That's different in Portland, but Portland's unique, that the neighborhoods actually have like legal standing. But, you know, the neighborhoods in New York, like, you know, you're on the west side of it, like, and the west side, you know, does the upper west side start?
The maps put boundaries between.
Or Brooklyn, let's say Brooklyn, where it's actually,
Right. And that's a big challenge for us. So when we ask people, you know, if they're looking for a store or something that's near them, assuming that they're in their house, what they're calling the zip code is a reasonable thing. Otherwise, you know, now you're asking, you know, what city. That's when it's really creative when people say things that aren't cities pretty often. Disney World, stuff like that. So grammar type of thing. And then they have neighborhoods.
I live in a little like
Yeah, they'll ask for
loop
stores in their
of the
neighborhood.
zip code, and none of the stores that I shop at are actually in my zip code.
Right. Yeah, there's no perfect solution.
yeah, I mean, if you geocode, if you have your, I mean, if you're a regular customer and you have your address, then you get a point. That's far better. I mean, zip codes are a complete data hack, but they're pervasive. They're a pervasive data hack. And they're easy, like, when you're doing a presentation. You know, if I just babbled census geographies, like I can do a little bit of that here, but I don't have to introduce zip codes. Like, I don't really know what that means. Do you use PostGIS? Or what do you? Yeah. What do you?
Well, when we use USPS data, we use the Canadian Postal.
Yeah.
Their data. We don't do UK stuff yet. We don't have any apps where we do that. But that, and then we use US Census data for cities. And so, so the US Census, we use populated places. So there are about 25,000 in the US.
Disney World might be one of them.
Disney World is actually not on the list.
It should be.
Another place that's not on the list, a lot of people would think, which is La Jolla. It's not an incorporated city.
Does it
Not
need to be
actually a city.
incorporated to hit the
It's
list?
a neighborhood of San Diego,
Yeah.
officially. And then there are a lot, then it gets complicated too, because if you just pull the data out of the US Census data, you get things like Nashville, Davidson County, because it's the county government and the city are combined
sort of amazingly good considering the
It's
challenge.
very useful for us, yeah.
Yeah, but anything else? Thank you all for